Good morning, all. I am Molika Patel, Assistant Professor in PP Savani University. On behalf of PP Savani University, I welcome all my students. We have to start the subject operating system. The subject code of this subject is SEIT2230. We have to study more topics on operating system. In this subject, I will teach section 1 module 2, that is process and thread management. In this chapter, we have to discuss many topics like the concepts of process, definition, the life cycle of a process, how many state of a process, then transition, process control block, CPU scheduling, context switching, preemptive and non-preemptive scheduling algorithms, scheduling criteria, algorithms like FCFS, SJF, round robin, and many more topics. The teaching hour of that topic, that is a 9 hours, and the weightage of that topic, that is a 20% among all syllabus. So let's start with our first topic, that is a process. Now, what is a process? So generally a process is a execution. A process is a sequential program in execution. You can say that whenever any program is executed, number of processes are executed. So you can define a process, that is the fundamental unit of computation for the computer. So components of process are, first one, that is the object program. That means the code to be executed via the process. The language of that program can be anything. Second one, that is the data. We have to given the data to execute our program. Third one, that is the resources. Whenever we are executing the program, sometimes it may require resource. The resources are many types. Maybe it required the hardware resources, software resources, based on the program which we have to execute. And last, what is the status of the process execution? That is used for verifying the status of the process execution. So you can say in a very simple word, whenever any program is executed, the number of processes executed means a process is a execution. For more detailed view of process, we can divide the process memory. We know that every process required memory to load and execute the process. So in terms of a process memory, that is divided into the 4 sections for efficient working of a process. First is a text section, is made up of the compiled program code, reading from non-volatile storage when the program is launched. Second one, that is the data section, is made up the global and static variables allocated and initialized prior to executing the main. Third one, that is the heap. The heap is used for the dynamic memory allocation and is managed via calls to new, delete, malloc, free, and etc. And fourth one, that is the stack. Generally the stack is used for local variables. Space on the stack is reserved for local variables when they are declared. Now sometimes the confusions are created. What is a program and process? So let me clear first what is a program and process. Let's start with the difference between the two. A program is a set of instruction or code that is sequentially executed to perform any task. But whenever any program is going for execution is called a process. Second one, a program is an passive entity. That means you can save the program, store the program wherever you require, and whenever you want, a program is there. So it is not required to execute the program every time. So we can say that a program is in a passive entity, but whenever the program is executed, a process is created. That's why a process is an active entity. Third one, that is, we know that the program is a passive entity. That means it resides in any secondary memory devices, whereas a process only resides in our main memory, because process is a live executions of our program. A program exists at a single place in space and continues to exist whenever a process exists in a limited span of a time. Program require sometimes resources, maybe not resources, but process consumes required resources. Last but that is not a least, a program does not perform the action by itself. Wherever the two or more processes could be executing the same program, each using their own data and resources. I hope you are clear about what is a program and what is a process. Let's move to the next topic. Our next topic, that is a process state. Now that is a very important state. How the process spend the time in each and every state. That means that is known as a process life cycle. Whenever any process is created and dead, in between their life, it go from the various state. So we have to discuss how many process state during their life cycle. So whenever the process executes, one by one the actions are performed, it change its state. So we can state first the two state process model, in which there are only two state of a process, not running and the running. So whenever OS create the process and enter into the main memory, that means whenever any process load into the main memory for execution, this time its state will be not running and this process are waiting for the execution. That means whenever the any process are waiting for a memory to loaded, it acquire the not running state. But whenever that process is loaded into main memory, it automatically change the state not running to running. That's why it has known as a two-state process model, not running and running. So whenever a process going for execution, its state is called running. Let's discuss more state of a process. Whenever any process is born or created, it acquires the new state. That means a process that has just created by the operating system but not submit into the queue for execution, it acquires the state that is a new. Second one, that is the ready state. The process is waiting to be assigned to a processor. When a process in main memory and ready for the execution, but execution is still not started, simply in that state a process must be loaded into the main memory and it acquire the ready state. During the execution, if any interrupt generated, by the system or the other process this timeout, then it will send back to the ready state. Now another state, that is a running state. When a process is currently executing by processor, then its state is called the running state. That means whenever a process is allocated to the process, it acquires the running state. A dispatcher will provide the process to processor for execution, and at a time only one process can be executed. If we have a single processor system, that means a single process can be executed by the processor. If we have multiple processor, means multiple process can be executed in a running state. Next state, that is a block or waiting state. The process is waiting for some event to occur. Let's say an example. Suppose any process required any input output resources like a printer, but that time our input resource printer is not available for a process, but process execution is required to printer. At that time a simply processor suspend the execution of a running state and send that process back to the waiting state. So this type of event whenever the occur, many types of events are occur, and at that times if some of the resources are not free, immediately processor send back that process to the block or a waiting state and select the next process from the ready queue for the execution, and this process will declare as a block process and it acquire the state block and waiting state. So you can say that in a simple word, when a process is executing and during the execution, if any event or IO operation is in a waiting for completion of a process, then process cannot execute until the event occurs. Now last state, that is the terminate. Whenever the task of process is completed, it automatically acquires the terminate state. Second one, whenever any process are killed by user or the system itself, even though the system process can acquire the terminate state. So a process will release by processor, it acquired the simple terminated state. Let's understand more clearly this 5 state via this simple diagram. It shows our 5 state starting from the new, then ready, between new and ready. That means whenever any process is born, it acquires the new state. Whenever any process load into the main memory, it acquires the ready state. Now we have a single processor system. So whenever a processor select any one process from the ready state via the dispatcher, it acquires the running state. Whenever any process is terminated or finish its execution, it go directly from the terminate or the execute section. But whenever the sum of the input out for any event occur, a processor suspend the running process and set back to the block and waiting. But whenever that event is occur, automatically that process loaded into again the ready state, ready to running and exit. So this is a very simple process life cycle diagram, and it has only the 5 states. Now already we have discussed a 5-state process life cycle diagram or process state model. Now we have to add another 2 state, that is known as a ready suspended and block suspended. It has a 7-state process state model. So discuss the first state, that is a ready suspended. in that process state, whenever the ready queue will be the full, some process will be suspended temporarily and store into the ready suspended queue, and its state is called the ready suspended. When ready queue will be free to store process, then process from ready suspended queue will store back into the ready queue. Another state, that is block suspended. When block queue will be full or some process will be suspended temporarily and stored into the block suspended queue, and its state is called a block suspended. When block queue will be free to store process, then process from block suspended queue store back into the block queue. You can more clear about whenever you see the diagram that is known as a 7-state process state model. See, you can see that new, ready, running, block and exit. There are 5-state model, but here we are added 2 more state, that is a ready suspended and block suspended, that we have already discussed what in the ready suspended queue happen or block suspended queue happen. So this is a simple process state diagram, how the process is created, and between two life of process, how many state is changing between the created to dead. Now let's discuss another topic of a process, that is known as a process control block, that is known as a PCB. Operating system provide the management of all the processes of a system, like the process creation, process termination, process execution and process scheduling, etc. So for that, OS maintain one table that store the history of a process about a process, and that is called a process control block. The short name, that is a PCB. It is also called the data structure of a process or the kernel data structure. So you can say that PCB is also TCB, that is known as a task control block or process descriptor or a process object. Let's move to this topic in a detail. This is a list of items that are stored in a PCB. You can say that pointer, process state, that we have already discussed. How many state in a process? 5 or 7. So that informations are also stored in a PCB. Another one, that is a process number, program counter, CPU registers, memory allocation, event information, list of open files. Let we have discussed each and every topic in a detail. Start with the first, that is a pointer. So a pointer points to another process control block. Pointer is used for maintaining the scheduling list. Information of processes are maintained as a linked list. Second one, that is a process state. Process state may be new, ready, running, waiting and so on. Third one, that is a program counter. It indicates the address of the next instruction to be executed for this process. Now next list information, that is a CPU registers. It indicates the general purpose register like state pointers, index registers and accumulators, etc. Second one, that is the number of register and type of register totally depends upon the computer architecture. on and interrupt this state, information along with program counter is saved to allow a process to continue correctly later. Next one, that is the memory management information. In memory management information, this information may include the value of base and registers, page table and segment table. This information is useful for deallocating the memory when the process terminates. Next, that is the accounting information. This information includes the amount of CPU uses by the process and real-time use, time limits, job or process numbers, account numbers, etc. So another information are also saved in a PCB, like the information about the CPU scheduling. That means which scheduling algorithms are used by the operating system to select any one process whenever the multiple processes are available in any state. Next one, that is the input and output resource management, then file management information, priority and so on. Now let's start our important topic of this chapter, that is a process scheduling. For that you have to clearly understand what is the scheduling. After that you have learned what are the algorithms are available for a process scheduling. So let's first understand what is the scheduling. We know that in a multi-programming system, that means more than one program are executed at the same time. Means more than one process and only one processor. Therefore, only one process can go for execution at a time, and rest of the process has to wait for execution. So for that task, OS is responsible for the scheduling of processes and controlling the execution of a process. For that it requires the use of CPU, that is a maximum quickly switch a process onto CPU for time sharing. So process scheduler select among variable processes for next execution on CPU. That means whenever more than one processes are ready for execution, a scheduler select any one process for execution. That is known as a process scheduling. I hope you clear about what is a scheduler. Again I am to repeat, whenever the multiple processes are in a queue for the execution, our scheduler select any one process for execution, and that task is known as a process scheduling. So process scheduling maintain the multiple queue. The first queue, that is the job queue. It is a set of all process in the system. Second one, that is a ready queue, set of all processing residing in a main memory, ready and waiting to execute. Third one, that is a device queue, that is a set of processes waiting for an input and output devices, and each device had its own queue. So process migrate among the various queue based on in which state the process has. Whenever process change its state, again it come from the next queue, maybe from ready to device queue, job queue or anything. So based on the state, a process queue is also changed. See, this is a simple representation of a process scheduling. Whenever any process loaded into the main memory, it go from the ready queue. So that happen in the ready queue. But whenever processor select any one process among the multiple process from the ready queue, it go into the CPU. Another queue, that is input and output queue. We know that suppose we have a number of limited input output resources, but that resources are used by any process and the system. So let's say a printer, maybe a printer is request by number of 3 to 4 process. So for that we have to maintain one queue to access the resource efficiently. So that queue known as the input and output queue, and for that any process request to use that resource via the input output request. Last last but whenever the time slot expired, whenever the multi-programming system or multi-tasking system had, maybe sometimes a processor or CPU gives equal number of time for each and every programs or each and program to create a illusion for user that the multiple programs are running. So many times whenever any process has limited number of time to execute, and whenever that time is expired, automatically CPU select the next process from the queue. So that is known as a time slot expired. The next one, that is the child execution queue, the fork a child. That means one process has a number of sub processes to perform the task. So for that you have to create the fork of a child. Last, that is the interrupt queue. Many a time due to the some event occur, interrupts are occur between the number of processes. So maybe it again go from the waiting state and waiting to the ready queue and again processor queue. So this is the simple the queues of a process scheduling. Now simply we have to understand that whenever a new process is put in the ready queue initially, it waits in a ready queue till selected for a execution. For next, whenever while executing the process, one of the several events could occur. First one, that is the process could issue an input output request and then place in an input output queue. The process could create a new sub processes and waits for its termination. And third one, that is the process could be removed forcibly from the CPU as a result of interrupt and put back in the ready queue. Now discuss the another topic, that is schedulers. Responsible for selecting a process for scheduling or operating with the resources. That means scheduler is a part that perform the task of a scheduling. So generally there are the three types of the scheduler: long term scheduler, short term scheduler, and the medium term scheduler. Long term scheduler is also known as a job scheduler. It selects which processes should be brought into the ready queue. Second one, that is a short term scheduler or CPU scheduler. It selects which process should be executed next and allocates CPU, sometimes the only scheduler in a system. Third one, that is a medium term scheduler. That is known as the intermediate level of scheduling. Let's discuss each and every scheduler in details. Let's first start with the long term scheduler, that is known as a job scheduler. It selects the processes from the disk and loads them into memory for execution. The short name long term scheduler, that is LTS. It controls the degree of multi-programming. That means number of processes in a memory. It invoked only when a process leaves the system. That means whenever a degree of multi-programming is stable a long-term scheduler is executed. The average rate of process creation is equal to generally the average departure rate of process leaving the system. So execution frequency is less in comparison of other, that means compared to the medium term or the short term. In a time sharing system, a long term scheduler is not used. Why? Because in this type of system, process directly put into the ready queue. So in time sharing system, LTS is not used. LTS needs to select good mix of CPU bound and IO bound processes so as to avoid the ready queue being empty with no work for STS or input output queue to be empty and devices not being utilized. Next, that is a CPU bound process. It generates the minimal or very few input output requests and does more computation. Last, that is a input output bound process. It does more of input output than computation. Now let's discuss the short term scheduler. Short term scheduler select the process from the ready queue which are ready for the execution and allocate the processor for execution. STS is a faster than LTS and STS is also called the CPU scheduler. That means compared to the long term and medium term scheduler, short term scheduler is a faster. It is invoked each time the CPU requires a new process for execution. Now let's discuss the medium term scheduler. Medium term scheduler provides the swapping. Swapping, that means a process is reside between the two from main memory to the secondary memory to the main memory. So ready queue and block queue are loaded into the main memory. So sometimes to reduce the degree of multiprogramming, a number of processes are suspended from the queue and moved to the secondary memory for the temporary time, and that operation is known as a swap out. But whenever that processes are loaded into the main memory, so that processes are swapped from secondary memory to main memory, and that operation is known as a swapping. So in medium term scheduler, automatically the number of processes are swap in and swap out based on the priority of the number of processes, and thus the swap in and swap out determined by the MTS, and that is used to decrease the load of the CPU, and it is also used to improve the process response time. Swapping may be necessary to improve the process mix. Using this diagram, you are clearly understand about what is a schedulers. Let's take that from ready queue to CPU. Whenever a CPU select any process from the ready queue, that is known as a short term scheduler. But whenever any time slice are expired, a number of processes are swap out to the secondary memory device, and again whenever the process are loaded into main memory, that is swapping, so that is known as a medium term scheduler. But whenever any process are required, the number of events are waiting for to occurrence or require input output resources that are not free, at that time that process are move into the waiting state and again go for the ready queue. So that is known as a generally our long term schedulers. But in the all the schedulers, whenever the process finish its task, it automatically terminate the state. Next point, that is our context switch. Let we have brief about the context switch. When CPU switches to another process, the system must save the state of the old process and load the saved state for the new process via a context switch. And the context of process represent in the PCB means whenever any process is suspended from the running state, operating system first save the work performed by the process, then it change its state. Whenever that process is again back to the running state, it start the execution where it's suspended. And for that, when any process change the state, it required the switching, and that is known as the context switch, that already represented in our PCB, that is a process control block of a process. It includes the value of the CPU registers, the process state and memory management information. When a context switch occurs, the kernel saves the context of the old process in its PCB and loads the saved context of the new process schedule to run. And for that, time dependent on hardware support, some hardware provides the multiple sets of registers per CPU and multiple contexts loaded at once. Context switch time is pure overhead because the system does no useful work while switching. Its speed varies from machine to machine depending on the memory speed, the number of registers that must be copied, and the existence of special instruction such as a single instruction to load or store all registers. Typical speed range from 1 to 1000 microseconds. So context switching has become such a performance bottleneck that programmers are using new structures or threads to avoid it whenever and wherever possible. Now move to the next topic, that is a dispatcher. It is a component of CPU scheduling function. It gives the control of the CPU to the process selected by short-term scheduler. Its functions include switching the context from one process to another, switching to the user mode. Third one, that is jumping to the proper location in the user program to restart the selected program. The dispatcher is invoked during every process switch. That means whenever every process is change its state, a dispatcher is required which process is selected by the scheduler. The time taken by the dispatcher to stop one process and start another process running is called the dispatch latency. Now again, more focus about the process scheduling. Again I have to recall what is the scheduling. So whenever more than one processes are available for execution, CPU select any one process or every state, consider as or select any one process for execution. To which process you have to select among multiple process, that criteria is known as a scheduling. So the act of determining which process is in the ready state and should be moved to the running state is known as the process scheduling. The prime aim of the process scheduling system is to keep the CPU busy all the time, to recover the maximum response time, and to deliver minimum response time for all programs. For achieving this, the scheduler must apply appropriate rules for switching processes in and out of a CPU. So scheduling has a two types. First one, that is a non-preemptive schedule, and second one, that is a preemptive scheduling. In non-preemptive scheduling, when the currently executing process gives up the CPU voluntarily, and in a preemptive scheduling, when the operating system decides to favor another process, preempting the currently executing process. In simple words, in a non-preemptive scheduling algorithm, whenever any process is selected by the processor until the process is not finished its task, a CPU cannot select any other process from the system. Whereas in a preemptive scheduling algorithm, a CPU suspend any running process and select another process from the ready queue for the execution. Why the CPU suspend the running process? Based on the number of priorities or the criteria of any process. But that favorism is happen in a preemptive scheduling algorithm. Whenever we have to apply any scheduling algorithm or perform the scheduling, first we have to learn the scheduling criteria. Based on this criteria, we have to decide which algorithm is best for any process. So let's discuss one by one all the scheduling criteria. First one, that is CPU utilization. In CPU utilization, to make out the best use of CPU and not to waste any CPU cycle. CPU would be working most of the time, ideally 100% of the time, but it is not possible to use the CPU 100% because it has several limitations. So considering a real system, CPU usage should range from 40%, that is known as a lightly loaded, to 90% heavily loaded. That means whenever CPU utilization is more, you can say that that algorithm is the best. Second one, that is the throughput. Throughput, that means the number of process completed per time unit. That means how many processes are completed per time unit. It is the total number of processes completed per unit time, or rather say total amount of work done in a unit of time. This may range from 10 seconds to 1 hour depending on the specific processes. Third criteria, that is the turnaround time. It is the amount of time taken to execute a particular process, means the interval from time of submission of the process to the time of completion of the process, that is a wall clock time. Fourth one, that is a waiting time. The sum of the periods spent waiting in the ready queue amount of time. A process has been waiting in the ready queue to acquire get control on the CPU. That means whenever any process is created, but when the process will get the chance to get the executed, in between the amount of time is wasted of a process, and that time is known as the waiting time of any process. It may be the sum or the total of number of queue that spent a time by any process. Next criteria, that is a load average. It is the average number of processes residing in the ready queue waiting for their turn to get into the CPU. Last criteria, that is the response time. Amount of time it takes from when a request was submitted until the first response is produced. So these all are the scheduling criteria. Based on that, we have to decide which algorithm is the best. Now another point, that is the operation on a process. That means how many operations perform on a process. That is first, that is a process creation. The process which creates other process is termed the parent of the other process, while the created sub process is termed its child. Each process is given an integer identifier terms as a process identifier or PID. The parent PID, PPID, is also stored for each processes. Second one, that is the process termination. By making the system exit or the system call, a processes may require their own termination. So these are the scheduling algorithm optimization criteria. Based on, you have to decide which algorithm is the best. So based on the criteria, we have to require maximum CPU utilization. Next, that is the maximum throughput. Third one, that is the minimum turnaround time. Fourth one, that is the minimum waiting time and minimum response time. So these are our best algorithm optimization criteria. These are the list of scheduling algorithms that we have to study in this chapter to decide which process to execute first and which process to execute last. To achieve maximum CPU utilization, computer scientists have defined some algorithms. They are one, that is first come first serve scheduling algorithm. Second one, that is a shortest job first, that is known as SJF scheduling algorithm. Third one, that is a priority scheduling. Fourth one, that is a round robin scheduling algorithm. Fifth one, that is a multi-level queue scheduling algorithm. Sixth, that is multi-level feedback queue scheduling algorithm. And seventh one, that is a lottery scheduling. So these all are the algorithms that decide which algorithm is best based on the number of scheduling criteria. So in this video, we have learned several number of points about the process. First, we have started what is a process. A process means a program in execution. After that, we have discussed the PCB, that is known as the process control block. It has a history of number of processes. That means OS maintain one table that keep the track of all the process. Later on, we have discussed what is the scheduling, scheduler, dispatcher, scheduling criteria, and these are the related terms to the process. And based on the scheduling criteria, we have decided the number of scheduling algorithm. Here there is a list of scheduling algorithm that we have to learn in this chapter. We will discuss these scheduling algorithms in our next video. I hope you are clear about what is the process, scheduling, scheduler and the dispatcher. And to understand the scheduling algorithm, first you have to clear the concept of the scheduling criteria that we have discussed. So at last, I am Moulika Patel. Thank you for listening this my lecture. Thank you very much all my students. Thank you.